When extending existing software, we usually try to do this in a non-breaking way. But that's not always the safest way. Let me walk you through an example. Imagine you're working in a codebase where this entity is part of the domain model. It shows the number of work items on a given day that have a certain state and are assigned to a specific area and iteration. This data structure is the core entity of an app called the Work in Progress Monitor. It visualizes how much work is in progress in a project over time. The idea is to keep work in progress limited, motivate the team to push work items into the done state, and so reduce the overall project risk. Large projects often use hierarchies of different work item types, such as functionalities, improvements, and work packages, to structure bigger features and changes. So far, the Work in Progress Monitor only shows work packages. The new request is to also provide monitors for improvements and functionalities. At first, this sounds like a simple change. But because it touches the domain model, it creates ripple effects across several layers. It affects the application logic that selects the relevant work items and computes values for the chart. It affects the local database used to cache historical data and the repository implementation that wraps access to it. And of course it impacts the presentation layer and the UI, because the user now needs to pick which work item type to display. With all these changes, how do we make sure we don't miss anything? Thinking about it, the key question is, how should we represent the different work item types in the design? Probably the most obvious option is to add a new field called work item type to represent the type of each work item. This is non-breaking in the sense that the code still compiles after the change. But that's where the problem starts. As soon as we change the repository to return snapshots of all work item types, the counts shown in the Work in Progress monitor will be wrong if we forget to update all the places where filtering by the work item type is needed. And the tests may still pass because most of them use fake data that currently only covers work packages. Of course, this design can work. If we carefully extend our tests and make sure we cover all new scenarios, we can deliver the feature successfully. But while this design is simple, finishing the task may not be. An alternative approach is to introduce a breaking change on purpose and let the compiler guide us to all the places that need updates. In our case, the natural point for this is the repository interface that returns snapshots. We change it to return a new type, snapshots collection, with dedicated properties for each work item type. This immediately breaks compilation in many places and creates ripple effects in 3 directions. First, the application logic. Code that previously expected a list of work package snapshots must now select the right property. To do that, the user's selection has to be passed from the UI through the presentation layer down into the application logic. Second, the real repository. It must now build and return a snapshots collection with all 3 lists. This also ripples into the local cache database, which needs schema and API changes. Third, the test setup. The fake repository must return a snapshots collection as well, which requires test data for improvements and functionalities, not only work packages. Now we have 2 ways to resolve this breaking change. Option 1 is to fix everything at once in a single commit. That means updating all directly broken code, plus the ripple effects these changes cause. This is the approach I prefer when the required fixes are simple and straightforward. But in this case there are too many different kinds of adaptations, so it would be too much for a single commit. Option 2 is to adapt the code step by step. The first priority is obviously to get the code compiling again. We can do this by using the work packages property of the snapshots collection everywhere a collection of work item snapshots is expected. Similarly, in the repositories we return a snapshots collection with empty lists for improvements and functionalities. With these changes the code compiles, the tests stay green, and we can commit. From here we adapt the code step by step. The key difference to option 1 is that we now have a clear API, the snapshots collection, which we can search for in the IDE with find all references. This ensures we won't miss anything. Typically, a good place to continue is the application logic. Here we decide which property of snapshots collection to use. For that we introduce a type that represents the user's selection. In object-oriented programming, that would be an enum. In functional programming, we use a discriminated union. Next we change the API of the application logic to require this selection. This is another intentional breaking change that makes the ripple effects clear. Don't use default parameters or option types here. This breaking change typically ripples in 2 directions. into the presentation layer towards the UI, and into the test API towards the tests. Let's handle the presentation layer first. We update the controller in the web UI to pass a work item type parameter. We then add a UI control so the user can choose which type to display. Next comes the test API. To satisfy the compiler, we let it pass only the initial type work packages first. Immediately after the commit, we propagate the work item type selection into the tests. This forces us to adapt and add scenarios for improvements and functionalities. At first these tests will fail, because the fake repository doesn't yet cover them. But once we update it, the tests go green again and we can commit. Finally, we use find all references on snapshots collection to check if any usages remain unadapted. The only one left is the real repository, so we update it too. And with this, we have successfully and safely integrated this change request. From my perspective, introducing compile time breaking changes on purpose to be behavioral non-breaking can often be not only safer, but also faster than relying purely on tests. And if you want to level up your refactoring skills, check out this playlist next.